Hello and welcome back to another video. So in this video we are going to solve again a Leetcode medium problem, and this is part of our DSA revision series where we are solving grind 75 problems. I'll uh, I'll add the I'll add the playlist link in the video description and I button in the top right corner. So without wasting further time, let me quickly jump into today's problem. So this is the problem. All node distance k in binary tree. So let's see what this problem says. We have given the root of binary tree and the value of target and an integer k. Return an array of the values of all nodes that have a distance k from the target node. You can return answer in any order. Okay, so for example, if target is 5 and k is 2, then 1 is 2 distance from 5. 7 is also 2 distance at from 5, and similarly 4. So this is more like a graph problem instead of tree, because once we convert this tree into graph, we can simply apply DFS for depth 2 and find all the nodes which are at distance 2. So we are going to apply similar approach. So I will have a map integer list integer. So this will be a adjacency uh, list. We will have a list of integer as answer, and we have another set integer for visited. Okay, so this distance k, in this I'll initialize all these. So first thing is graph, new hash map, answer as new array list, and visited as new hash set. Okay, the next thing is we need to build graph. So g- graph build graph will take this root, sorry, tree node root and tree node parent, so that I'll create a uh, edge for each of these kind of edge between root and parent. Okay, so this is the definition. Let me move it outside actually. So this will be build graph void. Okay, and here we call this build uh, graph root and null, because initially root has no parent. Okay, and here I can add the logic. If root not equals to null and and parent not equals to null, if these two are not null, then I have a valid edge and I can add it into my graph. So graph, we are a graph dot uh, graph dot what first we need to get the edge, which is uh, maybe we can use this function compute if absent. Okay, so this will basically create key if it is not present, otherwise it will fetch and do the operation whatever it is. So first we need to find root dot val. Okay, and if it is there, then we are good, otherwise it will create new array list. So we can pass something like k uh, k new array list. Okay, so we have initialized this, and we can add simply parent dot value. Okay, similarly for the other part, parent dot val and root dot value. So this is done, and now we need to check for subtree. So if root dot left is not equals to null, then we need to call this build graph for root dot left, and parent will be root. Similarly, if root dot right not equals to null, then we can call this build graph on root dot val, sorry, root dot right and root, which is the parent. Okay, so this is done, and next, so graph is ready. So next we can add visited dot add this target dot val, because we are starting from this target. Okay, now we can call dfs on root. Okay, dfs should be called like target, yeah, target and distance and the k, three values we can pass. So I'll quickly define this as well. Void dfs, first parameter will be integer target, or target, yeah, integer target, and distance int k. Okay, so to call this target dot value, initial distance is 0, k is k, and we can return answer at last. Now we need to define this dfs method. Okay, to start the dfs, the first thing we can do is basically check if distance is already k. Otherwise, for each neighbor we can call with the distance plus 1 if it is not visited. So that's the simple logic. So if distance is equals to k, then kind of we have reached the node, distance is k, then we can add answer dot add target and return. And in other case, for each neighbor, that is int uh, anywhere graph dot get target. If it is not visited dot contains, if it does not contains only, then I need to start Okay, so I'll mark visited dot add neighbor, and I'll call DFS again. So DFS DFS on this neighbor, which is neighbor with distance plus 1 and k. Yeah, to handle a null case, I'll add a new array list. Okay, get or default. Yeah, so our answer will be added. Sorry, our target will be added in the answer, and this looks decent. Let me quickly run this hash map where we have initialized hash map. Root dot right. DFS. Yeah, so 174 expected. We can return answer in any order, so this is correct. Let me quickly try to submit it. Yeah, so this is it. So in this video we have solved this all node distance k in binary tree, and I hope you like this video. So stay tuned for more, and I'll see you in the next one.